Hey there, and welcome. It sometimes feels like the whole world of AI has its own secret language, right? Well, today, we're going to learn the handshake. We're breaking down the absolute essential data terms that power artificial intelligence, and we're going to make it all super simple and clear. So let's jump right in with the most important idea of all.
So what's the big secret behind AI? Honestly, it's simpler than you think. An AI learns almost exactly the same way we do, from looking at examples. Think about it. You see enough pictures of cats and dogs, and pretty soon your brain just knows how to tell them apart. Well, AI does the exact same thing, but instead of using eyes and a brain, it uses things called data sets and features.
Okay, so if an AI learns from examples, what are the actual ingredients it needs to cook something up? Because just like baking a cake, you can't just throw things in a bowl and hope for the best. AI needs a proper recipe. So let's take a look at the flour, sugar, and eggs of AI's learning process.
First up, ingredient number one, the dataset. The easiest way to think about this is like the AI's personal textbook, or maybe a giant notebook. It's just a huge collection of examples. We're talking hundreds, thousands, sometimes millions of them, that the AI studies over and over to find patterns.
So what's actually in these notebooks? Well, that totally depends on what the AI is supposed to do. If you're building an AI for an online store, its dataset is probably going to be customer info. Age, what they bought, when they bought it. For a photo app, its dataset is literally just a library of thousands, maybe millions of images. And for a chatbot, you guessed it, a massive database of text conversations. The job decides the data.
Now, inside that dataset are the features, and this term, it is absolutely crucial. If the dataset is the whole puzzle, then the features are the individual puzzle pieces. They're the little clues, the specific characteristics that the AI uses to put the whole picture together and make a smart decision.
Let's make this real. To predict a house price, an AI needs features like, say, the number of rooms, its location, the total area. To understand a picture, it's looking for features like the colors, the shapes, the edges of objects. Without these specific little details, the AI is just staring at a bunch of numbers with nothing to go on.
And the final key ingredient here is something called labels. If we go back to our school analogy, right? The dataset is the textbook, the features are the questions in the textbook, well then the label is the answer key. It's the correct answer that we show the AI so it can figure out what right actually looks like. So for a spam detector AI, the label for every email is either going to be spam or not spam. Simple. If an AI is sorting animal pictures, the correct answers are cat or dog. The label is always that one specific thing, that outcome we want the AI to eventually learn how to predict all by itself. And this whole idea of having an answer key or not having one is what splits AI learning into two main paths. When the AI gets to learn with all the answers provided, we call that supervised learning. But what about when it's just given the data and has to figure it all out on its own, with no answers? That's what we call unsupervised learning.
So let's dive into that first method. Supervised learning is exactly what it sounds like. The AI is literally supervised. You can imagine it like a student in a classroom, and there's a teacher there guiding them, giving them really clear examples, and most importantly, all the correct answers.
And this quote just nails it, doesn't it? The AI gets a worksheet, that's our data set, and it also gets the answer key, which are the labels. By constantly checking its own work against those correct answers, it slowly but surely starts to understand the patterns and learns how to get it right.
This table here shows you the exact structure. Take a look. On the left, you've got all those features we talked about, things like age and symptoms. And then on the far right, you've got the corresponding label, the correct answer, like disease name. Every single example is perfectly paired with its correct output. This is what you use when you know exactly what you're looking for, like diagnosing a specific illness.
So what happens when there's no teacher in the room? No answer key to study from? Well, that brings us to unsupervised learning. In this case, the AI is basically thrown into the deep end of the pool and told to figure out how to swim on its own.
The absolute best way to picture this is to imagine you're dropped into a brand new city, but you don't have a map. You wouldn't know the official names of the neighborhoods, right? But you naturally start to cluster things together. You'd think, okay, this area seems like the shopping district, or, that area over there feels all residential. The AI does the exact same thing with data. It finds hidden patterns and creates its own groups from scratch. Now, look really closely at this table. You see what's missing? There's no label column. There's no answer key at all. The AI only gets the raw data. Its entire job is to look at all those shopping histories and find natural clusters of customers, all by itself. This is super powerful when you want the data to surprise you and show you patterns you didn't even know you should be looking for.
Okay, time to level up. We've talked about the ways an AI can learn, but what's the actual engine that does the learning? Well, that brings us to deep learning and neural networks. This is the tech that basically acts like a powerful artificial brain for the computer.
So, why do they call it deep learning? It's actually pretty literal. It's because the learning process happens across many, many layers that are stacked on top of each other. It's kind of like an onion. You peel back one layer to find another. The first layer might learn something really simple, like how to spot a straight line in a picture. The next layer takes that info and learns to spot a shape. Layer by layer, they build this deep, complex understanding of the whole thing.
And the structure that makes all this layering possible is called a neural network. It sounds fancy, but really it's a computer system that was inspired by how our own brains work. It's made of all these tiny interconnected neurons that pass information to each other from one layer to the next.
And the way information travels through it is actually pretty intuitive. The input layer, that's like our senses. It takes in all the raw data. The hidden layers, that's the brain, where all the really complex thinking and processing happens. And finally, the output layer gives you the final decision or prediction. That's the whole journey, right there. All right, you've learned the core language of AI. You've got the vocabulary down. So now it's time to put that new knowledge to the test. Are you ready? Cello, let's see how much you've really soaked in with a few real-world puzzles. Question number 1. Imagine you're building an AI, and its job is to automatically sort emails. The categories are already decided for you, spam and not spam. So which learning method would you use here? Supervised or unsupervised? Just think about it. Do you have an answer key? Okay, next up. An online store wants to find groups of customers based on how they shop. But here's the catch. It has no idea what those groups are yet. It wants the AI to discover them on its own. Is this a job for supervised or unsupervised learning? What do you think?
Let's get a little more specific with this one. Think about a self-driving car's AI. What are 2 features, 2 little clues it might use from its cameras to see the road? And then, what is one label, one decision it would need to predict from those features to drive safely? And for our final thought, you now have the foundational vocabulary to really understand how AI learns. But this is just the beginning of the journey. So what's the next thing you're curious about? What's one big question that this whole topic has sparked for you? Let us know. Keep asking questions, keep learning, and thanks for joining me.